Hello. Hi everyone. Hi. 여러분 안녕하세요. 저는 세라입니다. That's about it. That's all the Korean I know, and I'll be presenting in English, but it's really nice to meet all of you. Sorry I don't have like Korean subtitles for my presentation, but I hope that it's still good for everyone today. Cool. So I'll be talking about new possibilities on Filecoin. I'll cover some technology that some of you might be familiar with, things like IPFS, Filecoin that has been around for a while. And then I will cover the Filecoin virtual machine, which is something we just launched 2 months ago. So a little bit about me. Nice to meet all of you. I am Sarah. I'm a developer advocate for the Filecoin virtual machine team. So we are very focused on enabling applications to be built on the storage on the Filecoin network. We're currently in the midst of building a lot of different tutorials, new features, new documentation that has come up in the past week or so. So really in the middle of it, and we will be present at a lot of different hackathons, as some of you might have already participated in. So cool, let's get into it. Okay, how many of you have used, just a show of hands, how many of you have used Filecoin before? Okay, how many of you have used IPFS before? Awesome. Okay, yeah, I know. IPFS is awesome. I love it. And how many of you have used the Filecoin virtual machine before? Okay, not bad. For 2 months, 1 month each. Great. Okay, so today I'll kind of cover the things that I know it's a 2-day hackathon, and we have a lot of recordings online that go deep into it. I have about 25 minutes now, so I want to focus on what you can use during this hackathon and how you can get your project built today, right, in these 2 days to go ahead. So I'll talk a little bit about your different options for storage, and I'll do an introduction. You'll understand the concepts behind these 3 different buckets of technology, and then I'll do like a quick guide on what would be the best option for you to use in your hackathon project, and then introduce some quick resources that you can use straight away out of this, like starter kits, APIs, and so on. So let's make it super easy for all of you to hack. Okay, I'll start off with IPFS, and it's good to know that a lot of people here are familiar with it or have used it in some way. For those of you who are new to this, IPFS is a peer-to-peer network. IPFS and Filecoin are separate, and this is a common question that we get. So to clarify, it is separate from Filecoin. It is not a blockchain as well. It is a peer-to-peer network. The best way that I put it across to people is that it's kind of like torrenting, but it's legal. So that's what IPFS is. What you can do is you can store your data. You can use your own node, or you can use other people's node to keep your data there. So one really cool thing is about IPFS, and this is how we are different from a lot of file systems out there, is that we don't focus on where your data is stored as a location point for you to access your data. Instead, we focus on the data itself. So we provide content identifiers, content IDs for the data that you want to upload to the system. And so every single piece of data, no matter where it sits in the world, is something that you can identify just by the ID. So even if like computer A that you initially stored it on, or server A that you initially stored it on is no longer storing your data, it could very easily be passed on to server B, and you can still find your data over there. You wouldn't have to rely on server A like disappearing one day and you can't find your data after that. So content IDs are how we store your data, and that's how you can recognize it. One really cool thing over here is that we are in the middle of implementing a node that also sits in space. So this even proves the point that it doesn't really matter where your data sits, but we make it the easiest way for you to find your data. So if the satellite with the node in the future is like going across your location or going across Seoul, and it's faster for you to access the data from there, it could also ping off that node to get your data even faster. So we're experimenting with a lot of these things, and we're trying to bring data faster to people than it is today. So truly, truly decentralized all the way to space, and that is why it's called the interplanetary file system. So a little bit about content identifiers. I'm going to kind of get into how it works. So what you would do first is you would obtain the content ID for your data. And then you would then put it onto the IPFS network. This can be either, again, running your own node, or you can be using other people's node. And then you can use a data hash table to find the CID that pertains to your data. when data is stored on IPFS, it is actually broken up into a Merkle tree DAG. So that's immutable. So if you change any part of your data, the root hash of your Merkle tree DAG will actually change as well. So any data that you store, if there are changes to it, you would know based on the ID that you're trying to check it with, right? So that allows you to know like if there's any changes to your data, and it keeps your data more secure. Okay, so they kind of talked a little bit about this, about IDs itself. This is just kind of the difference between how it sits between a computer to Web2 and then to IPFS itself. And I also talked a little bit about this around how the CID works, but we won't be getting too much into it. It will actually be one of the underlying technologies for a very easy way to integrate this into your application, so I won't get too deep into this. But of course, if you want, we have documentations on this, and you can go read up more about it. Okay, and as I mentioned, so where you'll probably be using something that will relate to IPFS is around the step number 2 over here. So on top of step number 2, there are actually services today that run nodes and help to pin your content. When we pin your content, what it allows you to do is to retrieve the data really quickly. We have platforms that are built on top of it, like Web3.storage, NFT.storage, if you use any of those platforms. So those actually have SDKs and APIs that make it really easy for you to integrate in your application. So just to give you a sense of what it is, like what the backend is to the application that you'll be using, this is where it will sit on step number 2 over here. Okay, so that's IPFS as a whole. Now we'll get into the Filecoin, which is separate. So the difference between Filecoin and IPFS is that Filecoin is a blockchain. What we realized with IPFS is that you can store your data today, but it doesn't guarantee that your data is stored forever. So for example, if the node shuts down or they're not incentivized to keep it going, you might lose your data. So we created the Filecoin marketplace, kind of like a storage marketplace on top of that, and it incentivizes a whole decentralized network of storage providers. So we have storage providers, there are some in Korea, there are a lot in China, there are also a lot in the US that set up these hardwares on their own, or they choose how they want to store the data, and then they are incentivized through like a smart contract to store your data for you for the amount of time that you want to pay them for. And then once the deal ends, you can choose to renew it, or then your data gets dropped. But this guarantees that your data will be stored as long as you pay for it. So that's what the Filecoin network does. And we have a protocol there, and this is a layer 0 protocol. So this is the anatomy of a Filecoin storage deal. What will happen over here, and this is kind of good to know, but you don't actually have to use it in your application, in your hackathon project, but it's good to know, especially if you want to see which parts you want to focus in on or build tools or applications around. So first step will be always to do a storage deal proposal. This part is cool to know, and I'll explain it later, because when I talk about a Filecoin virtual machine, I will show you how this process gets a lot more automated with that new launch of the Filecoin virtual machine. So you will do a storage deal proposal. This will be using, this is how long I want to store my data. This is the CID of the data that I have prepared. Again, the data does not necessarily have to be pinned to IPFS, but you will have to transform it into a .car file format for it to be referred to in the deal proposal. So you would set all your parameters of how you want to store your data. You would propose it to the network over here. In step number 2, when your storage provider accepts the deal, they'll make the deal for you and put it onto the Filecoin network. And then they will continue to prove it over time, which is, we call it the proof of space-time. They will have to prove that your data exists, and your data exists the same way that it was uploaded, so it's the same piece of data. And then lastly, the deal renewal will come over here. So if the deal drops or the deal has ended, this is when you can, as a client, decide whether you want to renew your deal or not. So pretty complicated, right? We're making it a lot more easy with the Filecoin virtual machine. I'll talk about that in a bit. So over here, talking about what the steps that we have as a Filecoin network, like where are we headed? In the roadmap that we have, we're talking about scalable data storage. So we've invested a lot of time for the past 7 years building up the decentralized storage network. Now we are focused very much on data onboarding using usable and quality data onto the committed capacity that we have on the network. So we have one of the largest committed capacities right now. I think it's like 300 exabytes, but it's a huge amount of a committed capacity, and we're slowly onboarding a lot more data onto that. And then lastly, we're thinking about making data useful. So in this sense, we're talking about creating applications on top of the data that you have. And I'll address that in the Filecoin virtual machine part later on. But this is how you think of, this is useful to know like what the roadmap for Filecoin is. So as I was talking about, this is exactly where the FVM comes into it, and this is where things get exciting. So we launched this about 2 months ago, I think, 2.5, I don't know, time flies. We launched it on March 14th, which is actually Pi Day 314. We launched the Filecoin virtual machine, and what it does is to add programmability to the Filecoin network. What we foresee is that if you think about Web2 today, you have servers, you have data, and then you are able to create applications on top of that. So we want to be able to do the same thing, and we don't want to just be a storage network. So that's why we created the Filecoin virtual machine, so that you are able to compute the metadata of the storage deals. You know, remember how we talked about the storage deal cycle earlier on? So all those storage deals that are stored on the Filecoin network have like metadata attached to them, right? When your storage is stored until, what the data is about, how large the size is, and so on. The Filecoin virtual machine is then able to compute the metadata on-chain for you. So that allows you to create applications that are storage-focused, and you can manipulate or write custom logic to how you want to store your data, how long you want that data to be stored. Do you want to send it to a decentralized computation framework to compute a result and then send it back to the smart contract, and so on. So these are all the possibilities with the Filecoin virtual machine. A little bit about this, and to focus in on where we are, this is the architecture of the Filecoin virtual machine. Some of you might have seen this before. The Filecoin virtual machine was created to be an instance that is VM agnostic, but I know all of you were at ETH Seoul today. The first virtual machine instance, the first foreign runtime that we wanted to focus on was the Ethereum foreign runtime. Of course, because the EVM community is huge, and we want to be able to provide that storage capability to the Ethereum community. So we focus very much on providing full EVM compatibility. So if you're a Solidity developer, all your different tools with like MetaMask, Foundry, Hardhat, so on, will be compatible with the FVM. You will be using the tools as you are used to. The only difference is that you're deploying to a different testnet. So eventually, you will be deploying to the Filecoin network. So you can still, use all those. And we're working on partner integrations right now, like things like Telor as an Oracle, Axela as a cross-chain bridge, all these different things that you can use and that developers are familiar with, so that you have a very rich development environment that you are able to deploy to the Filecoin network. I do get the question as well a lot on why use FVM and not EVM. So the difference here is that you are really being able to do everything in a native environment. Of course, the impact here is not so much when you're developing it, it's more so when you deploy your application and you're actually implementing it. So you'll see a lot of differences in like a significant reduction in cost, especially to do with storage. So rather than writing in the EVM contract and writing to a storage platform separately where you're paying those fees, you could use it within the same environment, and so your costs go down a lot. Performance-wise, it's also much better. I can go into a deeper analysis there, but generally, performance would be much better using everything in a native environment. And so that's the main difference that you get with using the Ethereum, the EVM-compatible FVM that we have today. So as I mentioned, the really cool part, today, like before we had the FVM, people couldn't really do much with the storage. You could only store it and then retrieve it on the Filecoin network. But today, you are able to interact with the Filecoin protocol itself. So this is allowing you to go in and write like your own actors, which are the equivalent of smart contracts, on the Filecoin network. The way that we do this today, especially for Ethereum hackers, is that we have the Filecoin.solidity library. So this would be one of the tools that you can use in your projects to call the different methods that are using it in a Solidity contract, but then calling methods on the Filecoin network that you would use like usually with Filecoin. So in the, if you're used to Filecoin and you're using like Lotus, Go, and you're used to those methods on the Filecoin protocol, you can actually use it and call it from your Solidity contract as well. So things like, for example, checking the balance on my contract, checking the balance on my storage deal, checking how whether the miner has accepted my deal, how long is it being stored for. All these things you can call today from the Solidity contract itself, and not having to go into the Filecoin protocol and learn a whole new set of tools to be able to do that. So just a little bit of an example here. Yeah, we're super easy. We have some resources. We have a starter kit. You can just import that and then start using the methods yourself. So I did show you this storage deal flow earlier on. So now with FVM, the things that we are anticipating is that you will be able to write custom logic. A lot of the deal flow today, again, this is if you choose to write an application that automates the storage deal that or automates or improves the programmable storage market. There are a lot of things that you can do with FVM, and I'll talk about that in a bit. But one of the things you can do is to enhance the programmable storage market. So you could automate a lot of these things, especially to do with storage and retrievals. You could also decide if you want a certain event to then trigger off the storage to be stored automatically for your application, and a lot of cool stuff like that. So that's kind of how we see the FVM coming in and enhancing the Filecoin network. So we have a fully feature-complete JSON RPC, Ethereum JSON RPC API that we use for FEVM. So again, all the tools that you are familiar with, we have versions of it. Or if you're using MetaMask, you should be able to enter your Ethereum address, connect to our testnet, get our test fill into your OX address. So it's pretty seamless at this point, and you should be able to use the toolings that you're super familiar with. We also have things like we have a hard hat starter kit, we have a boundary starter kit for FVM, so these are things that you can fork and use. We also have explorers today that maybe if you're a Filecoin user, you might have used the Filefox Explorer or the Glyph Explorer, but today you can actually check on your transactions via the EVM-compatible FVM as well. I would say it's almost at Etherscan parity. There's a roadmap, but we're going to get there pretty soon. So yeah, if you're looking for ideas on what you can build, one example that I think is really cool is the data DAOs over here. I think maybe I've talked to some of you at the booth about it, but the idea of a data DAO and what you can build. So these are all examples of layer 2 solutions that you can build with the FVM on the Filecoin network. One of the really cool examples, and I would say play to your strengths, play to the storage capabilities of Filecoin. Data DAOs is something where you have a DAO, and your DAO is focused on a very important data set. So for example, if it's like users' credit card data, for example, you could write a data DAO where you have maybe you are able to collect all these different users' credit card data into a single data set, and then you are able to use the FVM to write access control onto that data set, and then only allow third parties to pay for access to your credit card data, and then contribute or attribute the profits back to the user themselves. So rather than your credit card data being taken by marketing companies and you don't get control over it, you could then pull it into a data DAO using FVM, get it stored, make sure that data is continually renewed via the treasury, via like automatic renewal of the data set itself, and then have that, and then be able to earn profits directly to the user just off of that data DAO itself. There are also different use cases, like maybe decentralized science. So if you want to upload a bunch of research papers into a data DAO, send some of those information out to a computation job to train an AI model, for example, and then return it back to the DAO to get those results. These are also things that you can do. But there's a lot that you can do with data DAOs itself. So really, really cool use case over there. We're really looking out for more projects in the data DAO space. There is also this resource list over here. So if you're interested in more ideas on how you can build your startups or your projects with FVM, there's a whole bunch of ideas over here that we've written out some descriptions for. OK, so a quick recap of what we covered so far, and then I'll hit straight into the resources that you can use. We have IPFS, which is storing data on a P2P network. We have Filecoin, which is storing data on the blockchain, your storage deals on the blockchain itself. And then we have Filecoin Virtual Machine, which enables you to build applications with the storage on the Filecoin network. And then, of course, if you've seen the Corgi biscuit before, this is the name of a Corgi that likes Filecoin. So it's one of our mascots. So what to use for your hackathon? So we built this, I want to say simple, but I realize it's actually not that simple. But if you have time and you go through the flowchart, you should be able to figure out what's the recommended path for you to use. Because you might be thinking, should I use IPFS? Should I use Filecoin? Should I use FVM? There are so many options. Which one should I use? This flowchart kind of takes you through. If let's say you want storage within your hackathon project, think about whether you want programmatic storage, which is automated, and you can write custom logic, or do you want non-programmatic storage, which is just a simple storage itself. Depending on that, and depending on the size of the data that you want to store, there are different options that you can use. So I would say the most easy for most people is simple storage, which is on the right side, non-programmatic storage. It stores any size of data. There are a lot of storage on-ramps that we have. So if you've heard of NFT.storage, Web3 storage, Filecoin data tools, these are all platforms that have done all the work that I mentioned to you earlier on in describing the whole data deal flow, putting it into a platform and then giving you a really easy API to use. So most of these will be JS libraries. You can use it and integrate it into your application. Wait, I will go through these in the next few slides before I get too deep into it. But if you're thinking of using programmatic storage, which is more automated, and you kind of want to get into the details, you want to write it yourself, think about the size of storage that you want, size of data that your solution will be storing. If it is below 4 GB, which is the recommended size for storage providers to pick up a piece of data, you might want to use something of a deal aggregation that takes small piece of data, like let's say it's like KBs or MBs, and then it pulls it together into a larger deal set itself, and then makes the deal for you. Or if you want to have a larger piece of data, like 4 GB, if it's a huge data set, you can just make the deal directly yourself, which is faster in its own way, and you get a lot more control over the process there. Oh, and also, this is a hackathon cheat sheet. If you want to go in there, it takes you through this flow, and it gives you all the links that you need for starting your application based on this flowchart. OK, so I talked about resource number 1, which was deal aggregation for small deals. This is one really good option. It's called Lighthouse.storage. This is on the hackathon cheat sheet. You can check it out. It is a very simple aggregator to use. I was going to click into it, but I also don't have my laptop connected right now into a browser window. But if you go to Lighthouse.storage, you can visit the documentation. They have an SDK ready to go. You can import the library and start using commands to upload your data, and super easy to use. What it'll do for you on the back end is to collect all these small pieces of data, put it together, and then set up a deal on the Filecoin network for you. If you have a larger piece of data and you want to do direct deal making, we have a custom contract that is already written out for you. You can fork it and start to customize it yourself. It is called the client contract. This will all be within the GitHub repo over here for FVM deal making starter kit. This is also within the hackathon cheat sheet that I shared earlier on. And I'll share it again at the end. So you can always fork that repo and start creating your own custom client contract. Again, both the first and second option will deploy to our testnet. So even though you are using Ethereum tools, you will be deploying to the Filecoin testnet and not like an Ethereum, another chain itself. And then lastly, I think this one would be super simple. I've skipped 3 and 4, only because those are a little bit more specific. But again, they are in the cheat sheet, and you can access them if you need. But here is resource number 5, which is for simple storage. So if you just want to store like the simplest pieces of data, storage is not the main focus of your application. You can use NFT.storage or Web3.storage. They have JS libraries that you can use to include within your project. OK, cool. And wasn't able to click into my browsers, but there are a bunch of links over here. I would recommend the one on the left, which has resources to the cheat sheet as well that I shared earlier on, as well as other tutorials and documentation for the Filecoin virtual machine. Again, that is really where you can start to build your applications. And then on the right side, if you want to join our Telegram group to get connected with other folks in Seoul, you can join the link over there. Cool. Yeah. Thank you so much.